All right, so what do we start with when we're graphing?
Finding the key questions, so start with the amplitude. And
Good.
the zero line, the max and the min.
Okay, good, stop there. So the zero line and the amplitude, and between those gets us the max and the min. So start with that. The other thing that you might say when you first start is identifying A, K, C, and D. You don't have to write them out. You're probably getting to a point where you don't feel like you have to, but it's always okay to do that. So if you were going to do that, A is negative 2 over 3. K is positive 2. Remember that one question that we did where it wasn't factored? This one is. Doesn't come up very often in this course, but it's something to be a little bit mindful of and careful of. C is positive pi by 3, and D is 1. And then exactly right, so I'm going to say, I'm going to pause and ask you to try this for yourself, the zero line and the amplitude to get the max and the min. Okay, go for it. All right. I think a lot of you got a head start because you're already done the whole graph. That's all right. Okay, so there it is. Zero line is your D value. Amplitude is your A value. What's the difference between amplitude and the A value?
The A value can be negative, the amplitude cannot.
Amplitude is always positive because it's like a length or a distance or something. It's a magnitude, right? So it's always positive, whereas the A is negative, and that gives us that reflection. So when we go to draw it, we got to remember to put that in there. And then the max is the zero line plus the amplitude. The min is the zero line minus the amplitude. And you know, if you just take quick notice, I hope at this point you're starting to get that much more comfortable with fractions, where this is starting to get easy. And again, your calculator can do fractions. You'll have your calculator for the test, so that won't be a problem. You know, I showed how I did this just with common denominators. 1 plus 2 over 3 is 3 over 3 plus 2 over 3, common denominator, right? So that's an easy thing to do without even having to punch it into your calculator. Once you get good at this kind of thing, it's easier to do it this way. It's faster than punching it into your calculator. But either way is fine. And you don't have to show this. It could just be 1 plus 2 over 3 and do that part in your head. Anyway, we get those fractional maxes and mins, so we're going to have to think about our scale when we get there. And then the next part of the 5 key questions is start and then and to me those 3 kind of go together because right they're giving us at least the start of the horizontal measurements. Good, so go ahead and do that if you haven't already. Okay, so there's that. Start, it's just your C value. The period comes from the K value, but you got to remember that little formula. Okay, you absolutely have to simplify things. Then the end, again, is kind of a tiny formula. Start plus the period gives you the end, and the way I use that is as a check that what you've done is correct. Okay, and then finally, use these properties to essentially figure out our X scale, right? Figure out that horizontal scale. Okay, so see if you can remember how to do that. Okay, so critical point distance is your period divided by 4. That's another little formula, all these little formulas. So period divided by 4, and then compare it to the phase shift. Sometimes instead of the phase shift, people get the end, or sometimes instead of the period divided by 4, people get the end and divide by 4. It's just a weird little thing because you've got the 3 of them in a row there, right? You've got all 3 of them, and so you kind of pick the wrong one, so be careful of that. And then you get a common denominator. Pi by 12 is a common denominator between 4 and 3. So you don't have to write all this out, 1 square, 2 square, 3 squares. I'm doing that for the lesson. If I said pi by 12 was 1 square, why would there be 3 squares between critical points? Because the critical point distance, pi by 4, 4 times 3 gives me the 12, therefore 3 squares. Right? 1 pi by 12, 2 pi by 12, 3 pi by 12. That's pi by 4. So that's 3 squares, counting by pi by 12s to get to pi by 4. If I chose to make it 2 squares, because you can't make it 1.5 or anything, so the next one is 2, okay? Then I would have to double that. Because every time I want to go pi by 12, that's 2 squares. So 2 squares, 4 squares, 6 squares. Okay? And in this case, because the grid is a little bit small, it doesn't fit. I tried it. It won't fit. Why won't it fit? Mainly because our phase shift is positive. So when I go to draw it, even if I put the y-axis as far over as possible, 6 squares means you need 24 squares from the start to the end, right? Because you're going 6, then 6, then 6, then 6, so 6 times 4, so it's always times 4, right? Same as that 4 for the critical point distance. So I need 24 squares, and because of our phase shift, we start too far over. 24 goes just off. I think it's by like 1 square. It's just off. So we are stuck with this one where pi by 12 will be 1 square. So 3 squares between critical points. So go ahead and try that. So notice what I did here. I put my y-axis almost as far over as possible, and my x-axis almost as low as possible. And it's a little extreme. In the end, we're not going to need that much space. But the max and min are both positive. Obviously, if the min is positive, the max is positive. You can't flip them. Right? So the min is positive, so everything's above the x-axis, and it starts to the right. It starts at a positive x value, positive pi by 3. It So the whole graph is also going to be to the right. So why bother wasting space to the other side, right? And this is something that you have to consider. And on the test, I'm not going to make it too hard, but it is something you have to consider. And one thing we talked about is you don't put your axes just in the middle of the grid like that. Okay, so you got to take some consideration into where you're putting them. Obviously draw them with a ruler. That was another thing from the learning goal. Some people didn't, so get a ruler for the test for sure. They're up here, there's lots. And then start marking your scale. The y values are in thirds, so you're probably going to count 1/3, 2/3, 3/3, or maybe you could do like 2 squares as a third, and that's just a preference. Stretching it out is usually a good idea. You don't have to overdo it. You don't have to go crazy about it. If you can fit it and make it a little bit bigger, it usually looks a little bit nicer than being really crammed in. But you know, like I said, you don't have to overdo it. And same thing, stretching it sideways. You know, if you can fit more squares in, then I would say try. Like, give it some consideration and do it, but don't go crazy. 1 square between points is never enough. That's not okay. Okay, there was one question in the homework where you had to go with 2 squares. Generally, 3 or more is better. What's the last thing we have to consider before we graph it? 2 little things left that we talked about when we took up the learning goal.
Which graph you're actually graphing, if there's a reflection.
Good. Are you graphing sine or cos? And is there a reflection? And in this case, there's both. Okay, so there's the graph. I've marked my scale. I was counting by pi by 12, so I marked every 4. 1 pi by 12, 2 pi by 12, 3 pi by 12, 4 pi by 12. In this case, why did I choose that? Well, because that was my first point. It kind of made sense, right? Makes it a little bit easier because now my point is marked. Now my next marking isn't one of the points, and that's okay. So some people have been asking about that, and again, that's a common question. How do those have to match up? They don't have to. But if I'm choosing between marking every pi by 4 or marking every pi by 3, well, I'll choose pi by 3 because in this case, that's where my phase shift is. It makes my life a bit easier. It's also where the end is. The end was 4 pi by 3, so that's easy to find. And I don't have to go counting squares to figure out where it's actually at, right? But the other 3 points didn't line up, and that's okay. You and I did 3 squares to 1, 3 squares to 2, so there's a third, and I reflected it, and it's sine, so everything's good. On the test, there will be a question that's intervals of increase and decrease, but it'll be with a given graph, not one you have to graph, because if you didn't graph it, then you would lose more marks because you wouldn't be able to answer it. But that is something else to consider, that if you have to do intervals of increase and decrease or positive negative intervals, we don't really do with trig functions because it's harder, but you know, any kind of domain range, anything like that, you know, you are going to have to figure out where all these points are eventually, right? Any questions?